Most developers can ship features and close tickets inside an existing codebase, but the moment you ask them to design a system from scratch, they freeze. That ability to navigate ambiguity is exactly what companies pay senior salaries for. Senior engineers don't start with Kubernetes or distributed sharding. They start with the single server model. Every complex system begins as a single box containing your web app, API, database, and cache. The flow is simple. The user hits a domain, DNS resolves it to an IP, and the server processes the request. This architecture works, but it has a ceiling. As traffic grows, your CPU spikes, RAM fills up, and a single crash takes down your entire business. This is where senior thinking kicks in. Instead of just adding tech, you identify the bottleneck. The first step is separating concerns. Split your web tier from your data tier so they can scale independently. This forces a critical decision. Which database do you choose? Juniors guess, seniors analyze trade-offs. If you need strict structure and ACID transactions like for payments or banking, you choose a relational SQL database like PostgreSQL. If you need flexible schemas and massive write throughput, you opt for a NoSQL solution like MongoDB or Cassandra. You don't pick based on trends, you pick based on data structure. Once the data is handled, you have to scale the compute. You can scale vertically by buying a stronger server, but that has hard limits. The scalable answer is horizontal scaling, adding more servers. This introduces the load balancer, a critical component that distributes traffic using algorithms like round robin or least connections to ensure no single server drowns. This redundancy eliminates single points of failure. Finally, you must design the communication layer. Your API is a contract. Whether you choose REST for simplicity or GraphQL for efficiency, the interface must be predictable and consistent. You need to look even deeper at the protocols. Are you using TCP for guaranteed delivery or UDP for raw speed and streaming? And you must assume the system will be attacked. Authentication answers, "Who are you?" while authorization answers, "What can you do?" Real security includes rate limiting and input validation baked into the architecture, not added as a patch later. System design isn't about memorizing tools, it's about clear thinking under uncertainty. This is SWE Codes,